Let's talk. I don't mean a convo, I mean this talk. So torque is a very basic concept in physics and engineering, and it's basically a measure of the tendency for a force to cause something to rotate about an axis. Torque is given the symbol tau, the Greek letter tau. So it's pronounced tau. And it's got units of Newton meters, or N for short. This is the distance between the pivot and point of applied force. And R is measured in meters. SI units for distance is meters in physics. F is the applied force. That's measured in newtons. So it makes sense for torque to be in units of Newton meters. You've got theta. This is the angle between the lever vector and applied force. Okay, typically measured in degrees. So here's your formula. This is presented on the HSC formula sheet. You don't need to memorize this, but you do need to understand it, as is the case with the other formulas. I'll explain how this all works visually. So mathematically, this is how torque is calculated. I'll show you how to understand this visually. Okay, suppose you've got here a hexagonal nut. That center here, so let's suppose you've got a spanner. So excuse my sketch of a spanner. Here's a spanner. And suppose this is the center. This is called the pivot. Okay, the axis of rotation is here. This is the point about which you're turning the nut, the hexagonal nut. And suppose you're applying a force upwards, let's call it capital F, are on top for vector. So this is the magnitude of the force, of the torque. So we've left out all the arrows on top of the torque, distance and force, because this is the magnitude of torque. That's how you calculate the size of torque. Torque, it's worth mentioning, is a vector, because the force, the applied force, is a vector, and so is the distance r. And this here is the lever vector. So let's call it L, I should say R. So R is basically the distance between, as we've defined here in the formula, it's the distance between the pivot and the point of application of the force. So that's visually what's happening. You have a spanner, you have a hexagonal nut, and you're applying a force, let's suppose 90 degrees to the pivot point. When you do this at 90 degrees, so the angle between, so theta is the angle between the applied force vector and the lever vector. When you do this, here's what you find. Torque becomes this, sine 90 degrees. Sine 90 is 1. So the formula reduces to this. This is your maximum torque. To get maximum torque in any situation, the applied force vector must be perpendicular at 90 degrees to the lever vector. Okay, any other angle less than 90 degrees, it's going to give you less torque. This is how you get the maximum torque. And once again, to emphasize, torque is a vector. So suppose the applied force, so I'm turning the spanner counterclockwise. The torque in this case, whatever the number is, let's say it's x Newton meters, you would write counterclockwise or anticlockwise. So So suppose you have a calculation that you're working on. Your answer should be in the form of a magnitude, a number for torque, and a direction. I've got a nice demo here. If you've got like spare pieces of timber lying around, some spanners and some bolts, nuts and bolts, this will be a great demo for a Year 12 physics class. Let's pretend for now that the bolts are of the same diameter, which are not in this case because it's a bit hard to find. But pretend that there's only one independent variable, and that's the length of the lever vector. So all these spanners here, in other words, they're different lengths. Pretending that these are the same diameter bolts, you would notice that with a longer lever, right, turning this bolt will be a lot easier with a longer lever than a shorter lever, because according to the formula, if you increase R, you increase the torque, and vice versa. So that's a nice, neat demo here. It'd be good to have this scattered around the class in groups, so groups of, let's say, 4 or something, if it's a small class, and then get students to rotate and write down their results. They can actually calculate. Suppose for some fixed force, they can measure the distance of the lever vector, and just experiment with the different spanner lengths to demonstrate that a greater lever vector, a greater distance from the point of the applied force to the pivot point will result in a greater torque. You can even try different angles, but that's the concept of torque.